Good morning, Precalc. It is a lovely cold day early in the morning in December, and I'm recording this video for you for sometime in January or maybe May if you're in the spring group. So, let me get you started. Arithmetic, we're going to start a chapter on sequences today. So, sorry, my pen isn't working, of course. The definition of a sequence that I looked up is a numerical sequence is a set of ordered values of a function whose domain consists of the set of all natural numbers in ascending order of the numbers. The elements of a sequence are called the terms. That is important, okay? They're called terms. The nth term is called the general term or variable of the sequence. So let's just go with it's an ordered list of numbers, okay? This business about domain consists of a set of all natural numbers and counting. So it's term 1, term 2, term 3. There's no decimal term numbers and all that good stuff is what that's saying. So specifically an arithmetic sequence is when you have an ordered list of numbers where the terms have a common difference, okay? So term 2 minus term 1 or term 22 minus term 21 are always the same difference. So let me give you some examples to help this make sense. We could start with 7 and go up by 2s. We could start with 20 and go down by 5s. We could start with 8/3 and go down by 1/3. Now when we get to 6/3, that would be reduced. Okay, so it can go up or down. It can go up by a constant positive value or negative value. It can go up by a decimal or a fraction or down. So in this example, the difference was positive 2. In this example, when we do 15 minus 20, we get a difference of negative 5. In this one, we have a difference of negative 1/3. Okay? What did the question ask? Just to define what it is and give some examples. Okay. It says over here an arithmetic sequence have a constant rate of difference called d. So you can take any term and subtract the previous term to find that difference. Now I'm going to write that in notation that'll make more sense after we do the next page. But a sub n minus a sub n minus 1 would be the difference. Now we're going to talk about what that means in just a second. All right. So an explicit form for a sequence allows you to find the value of any term in the sequence. It is based on the term number. Okay. So when you have, let's talk about some vocab here. A sub n equals the nth term of a sequence. So a sub 5 equals the 5th term. A sub 1 equals the 1st term. Wow, I can't spell. I also can't get my eraser to work. All right, and this is where you have to get a little tricky. If you know the term, say term 7, and you subtract 1, that would be term 6. So this notation means the previous term. D is the difference. All right, so explicit form of an arithmetic sequence means, let's put one up here and talk about it. 5, 7, 9, 11. Okay, so to find the 27th term here, you would say any term I want to find, I take the first term and I add the difference, but it's n minus 1 times. Let me talk you through that. So to find the 27th term of that sequence, I don't know if that's what I just said or not, but we're going to do it. You would take 5 and add 2, but you don't need to add it 27 times because you already know the first term. So you're going to actually add it 26 times. So 5 plus 2 times 26 would be 52. Would be 57, would be a sub 27, or the 27th term. Okay, that's just an example. This is the formula that's called the explicit form for an arithmetic sequence. You start with the first term and you keep adding a difference, but you don't add the difference the first time, so you subtract 1 to say, I need that for the second, third, fourth term, etc. Okay, that's called the explicit form. And it is based on the term number n. Now a here's a little slide that shows it. So this is just an extra slide again. They put the D at the back, it doesn't matter. All right, if you have a formula, they will also simplify it. For example, if you were doing this, you would say a sub n equals 2 plus 3 n minus 1 times. And so you would get 3 n minus 1. These are equivalent. Okay, this is just simplified. All right. A recursive form of an arithmetic sequence is one that is based on the previous term. Okay, so any term is, remember we talked about this, meaning the term before, or the previous term. What in the world did I just write? It's kind of like the term, but I combined the words. Oh my goodness. It's too early for me to make a video, obviously. So you would say any term in my sequence is the term before it plus some difference. Let's make one that's negative this time. So if we had negative 1 and we subtract 4 and we subtract 4 and we subtract 4, and that was our difference, okay? For this sequence, you would say a sub n equals the previous term minus 4. But there are always two parts to any recursive formula. You have to also tell me what the first term was. Okay, so you have to tell me how to get to the next term, what difference to add, but you also have to tell me what the first term was. And you can do that in any order. I'm not going to be picky. So over here, it was some sequence where you're subtracting 4, but you had to tell me the first term was negative 1. So this would be the recursive for this particular one. All right, so recursive is simply telling me how to get to the next term based on some starting term. So we're going to go through some examples real quick here. And there are a few I might skip and let you do after the video. All right, so this one, if we do negative 30 minus negative 24, or negative 36 minus negative 30, which is useless because you guys can all look and say, oh yeah, it went minus 6, minus 6. But if you did this, you'd get negative 6. You did this, you'd get negative 6. And it continues to do that. Okay, make sure it does every time. So you would say, yes, it's arithmetic where the difference is negative 6. Now, they're much harder to tell when they're fractions. You can take any term and subtract the previous term. And see if you get a common difference. Another way to do it is to make them have a common denominator. So 3 is really 9/3. And then if you look at this, you get a difference of 5/3. Here you get a difference of 5/3, and here you get a difference of 5/3. So this is yes with a difference of 5/3. So any term, take away the previous term, should give you the difference. Okay. Again, if you had just written this as 9/3, most of you would have said, oh, the top's going up by 5. All right. I'm guessing there's going to be one that's a no here. Let's see, this one went down 1, then this one went down 4, then this one actually goes down 18, so this is a big no. And it's not even geometric, which we're going to learn later is when you multiply by something, because it's not working for that either. All right, so find the common difference and then list the next 3 terms that come next. Okay, I'm going to skip this one, let you guys go back and do it. And I'm just going to do this one. If we look here, we might, since they've already told us there is a common difference, we might be able to tell right here that what happened is it went down 2/3. I'm going to rewrite them all with a 3 denominator. 2, if we multiply by 3, top and bottom is negative 6/3. And if we multiplied here, top and bottom, we'd get negative 12/3. So then it's a little bit easier to see that the difference is negative 2/3. And then the next 3 terms, if we keep subtracting 2/3, okay, the next one would be negative 14/3. After that, if we took away 2 more, we'd have negative 16/3. The next one, if we took away 2 more, would be negative 18/3, which is actually negative 6. So there's the next 3 terms reduced and written the way they had them. All right. This says find the common difference and then find the 52nd term, which you would call A sub 52. All right. Is it going to do both of these? Maybe I will real quick. This one, if you notice, is going down by 8. This one, if you notice, is going up by 20. And again, all you have to do is type negative 5 minus 3 is negative 8, or 16 minus negative 4 is 20, or 56 minus 36 is 20, okay? They've told you that there is a common difference, so you don't have to check every set. So then, to find the 52nd term, we're going to go with the formula that says any term, we're looking for the 52nd, is the first term plus the difference n minus 1 times, but we're putting in n equals 52. So we're going to say the first term plus the difference, 52 minus 1 times, or 3 plus negative 8, 51 times, gives us negative 405. Okay, and on this one, again, we're looking for the 52nd term, so we would say the first term plus the difference, 52 minus 1 times, so negative 4 plus 20, 51 times is 1016. Okay. Obviously, you should be using your calculator to find these. I'm just trying to keep the video short. Okay. The explicit form is based on the term number. So all we're doing is putting in values and then simplify. I guess I can do both of these if needed. I think you guys could do number 12. Let's see, what is the difference here? So 12 fifths minus 9 tenths. Well, you could use your calculator, or this is 24 tenths minus 9 tenths. That would be 15 tenths, or 3 halves. Let's see. Let me fire up my calculator here. I'm going to do a different set of 2. So what if we took 27 fifths minus 39 tenths? Okay, it is going up by 1.5. You see that? Or 3 halves. So the formula would be any term is the first term plus the difference and minus 1 times. Now, to simplify that, I'm going to distribute. And then I'm going to do 9 tenths minus 3 halves to combine those. I know some of you would go to your calculator. Which is negative 3 fifths. So we have, and it doesn't matter what order you list it in, I'm going to put this first and then say minus 3 fifths. Okay, so for this one, you would have 30, the difference is going down 8. And then you just need to simplify. I think you guys can finish that one. And that's the explicit formula. Okay, this says given the explicit, which means based on the term number, find the common difference and the first 4 terms. So you would put in n equals 1, 2, 3, and 4. So if I put in a 1 here, I get 197 minus 200 once, which would be negative 3. If I put in a 2, I get 197 minus 200 twice, or 400. So I get negative 203. 197 minus 400. Yes. So the third time you do that, 197 minus 200 3 times, it's down to negative 403, and I'm thinking you can tell what the difference is, okay? The difference is the negative 200, and the fourth term would be negative 603. Is that all they wanted? Common difference in the first 4 terms, okay? So I think you guys could do this one. You will notice that this is going to be the common difference. So here, when you put this in, okay, if you put in a 1, you get 14.4. If you put in a 2, 12.1 plus 2.3 times 2, you get 16.7. And then all you're doing is adding 2.3 because whatever is multiplied by n is always going to be the difference. So I'd have 19 next and then 21.3, if I did that right. Trying to check my key, and I'm not on the right page. There we go. All right. So find the recursive formula. Okay, given the recursive. Okay, so given the recursive, which means based on the previous term. Find the common difference. Well, guys, the recursive formula says a sub n equals a sub n minus 1 plus the difference. So the difference here is 2, and the difference here is negative 1.1, and then find the first 4 terms. Well, I'll do one of these, but this one tells you the first term is negative 21, and then you're supposed to keep adding 2, adding 2, adding 2. Okay, you guys could do this one. You'd start with negative 2.6, and then you keep adding 1.1. Or subtracting, sorry, because the difference is negative. Okay, find the recursive formula. So we need a sub n equals the previous term plus some difference, and the first term is, and you have to tell me what that is. So here you could say the first term is 16, and to find the next term, I take the previous term and add, what are they adding here? Negative 9, the difference is negative 9. So they're actually subtracting 9. Now when you write this, I didn't make a big deal about this before, I should have. These are subscripts, so it's a real little n down here, and this is a little n minus 1, and then this is a big minus 9 up here, okay? Where the first term was 16. I just rewrote it, doesn't mean anything. Okay, so here, let's see, what are they doing? They're going down by 1/2. So you could say the first term is 3/2, doesn't matter what order you do this in, and the next term is the previous term minus 1/2. Okay? Given the explicit term, find the recursive term. All right, this is just about understanding what's going on. So n is the term number, and it's been simplified. But whatever's multiplied by n is the difference. Again, you could put in n equals 1, 2, 3 to find the first 3 terms. If you put in a 1, negative 26 plus 30 once would be 4. You put in a 2, you can do it on your calculator, negative 26 plus 30 times 2 is 34. And then it's going to keep adding 30. All right, now it says find the recursive term. So you can tell me every term is the previous term plus 30, where the first term was 4. Okay, actually going to let you guys do 20. All right, number 21 says find the term named in the problem and the explicit formula. So this time they want us to find the 30th term for this one, okay? And the explicit formula, well, we might as well find the explicit formula first, because then we can just put in a 30. So a sub n equals a sub 1 plus the difference n minus 1 times is the explicit form. So a sub n equals negative 33 plus, this is going up by 8, n minus 1 times. Now if I wanted the 30th term, I would just put a 30 in here and say the 30th term is negative 33 plus 8, 29 times 30 minus 1. Negative 33 plus 8 times 29 is 199. But you could have also simplified this first. Eight n minus, I will subtract that wrong, 41. Okay, so this is the simplified explicit form. And then you could have said, I'm going to put a 30 in here. So you do 8 times 30 minus 41, and you get 199. Okay? So it doesn't matter at what point you put that in. So a sub 30 is 199. So we found the 30th term and the explicit formula. I'm going to let you guys do 22. Looks like the difference is -2. I'll do that one in the notes with you. Okay. Given two terms, find the explicit formula. Okay. This gets a little bit tricky because students want to do some kind of n-1 business. But basically from here to here, the difference has been added 16 times. You just subtract the term numbers. So then you say 3819 plus 16 differences gave you 7019. Okay? If you subtract $3,200, so then 16 differences is 3,200. If you divide 3,200 divided by 16 is 200, right? Okay. So we, given two terms, find the explicit formula. Okay, so we still need to know the first term. So we could say the 20th term minus 19 differences would give us the first term. So 3819 minus 19 times 200 would give us the first term, and this turns out to be 19. So this sequence was 19 plus 200 and minus 1 times. That is the explicit formula. In the notes or on the answer key, they would simplify that. Let's see, that would be 200n. And then if we had 19 minus 200 back here, get minus 181. All right, let me do another one of those. Definitely a little tricky. So here to here is a difference of 40 minus 16 is 24 terms. Differences were added. So you got to think about that as -73 had 24 differences added and became -217. If I solve that, -217 plus 73 is -144. Divided by 24 is -6. So now to go back and find the first term, okay, I do a separate problem. I go up here and I say the 16th term, okay, the first term plus 16 differences got us to -73. So a sub 1 plus 16 times -6 was -73. -6 times 16 is -96. So if I add 96 over here, the first term was 23. So my sequence would be a sub n equals 23 minus 6 n minus 1 times, which if you simplify, let's see, would be 23 minus 6n plus 6 would be 29 minus 6n. And I really don't care if you leave it like this. All right, is that what they asked for? Just the explicit? Did I miss anything? Okay. And now if it asked for, like, what is the 30th term, you just put a 30 in. Okay, how'd we do? All right. That's the notes, so you finish, and then there's some practice, a worksheet for you today.